Okay, here is the podcast that you will need for section 4-6, which is hypotenuse leg. In the past, we have talked about not using SSA or the backwards version because that's the donkey theorem. However, SSA can be used in one kind of triangle, which is a right triangle. So it has a completely different name. And so the purpose that we're going to study is we're going to be studying HL, which is this bottom one. That's when we have a hypotenuse and a leg of one right triangle to be congruent to the matching hypotenuse and the matching leg of the other triangle. And if that happens, then the two triangles are equal. Now, there are such things called LL, HA, and LA. However, you'll see once we have a picture, you'll see why we kind of don't talk about them. LL stands for leg. HA stands for hypotenuse acute angle. LA stands for leg acute angle. And of course, you know HL stands for hypotenuse leg. Here are the pictures for these. As you can see, LL looks a lot like our other friend, SAS. So again, why learn a new technique for it? Doesn't pay. HA, hypotenuse acute angle, is nothing more than an AAS version. So again, that's why we don't really talk about it much. LA, the same thing. It's an angle side method. So again, don't learn anything new. The new one is HL, and we kind of talked a little bit about it on and off throughout this chapter. So HL is when you have a hypotenuse and a hypotenuse, and then a leg, and of course you have to have two 90-degree angles because they have to be right triangles. So first we're going to identify whether they are right triangles by HL or not. So for the first one we have just a 90-degree angle. So therefore the answer to that would be no, just because we have just 90-degree angles and no other information. Number two, we do have HL. The hypoteni are equal. That's the plural of hypotenuse. And then the legs are marked equal. So then we want to write the triangle congruency. So triangle ZRS is congruent to triangle ZTS. The next example, the tick marks are a little goofy, and I guess I don't know if I really like that on that one, but because of the markings, it still would be HL, so it would work. Triangle LMN would be congruent to triangle RVS. So we have that. And then the last one is also HL. We have a hypoteni from each piece. We have the legs from each piece. And again, triangle OPQ would be congruent to triangle ZYX. Next, let's incorporate some algebra. So if we're going to be working with solving this, first of all, this one's very simple. The hypotenuse and the hypotenuse have to be the same. So it's going to be 17. Done. The next one, you'd first start with the hypotenuse being equal to the hypotenuse. So 4x plus 1 equals 13. Subtract 1 both sides. 4x equals 12. Divide by 4, get 3. Now you want to set the two legs equal. So 2x plus y equals 8x minus 2y. Plug the 3 that we found in for x. So 2 times 3 plus y equals 8 times 3 minus 2y. 2 times 3 is 6, so we have 6 plus y equals 8 times 3 is 24 minus 2y. So we'd add 2y both sides to get 6 plus 3y equals 24. Minus 6 both sides, and then get 18, divide by 3, and y is 6. Lastly, this is about using right triangles and HL. So with a proof, again, you'd put in your given, just like always. We are given that the hypoteni are equal. So we have WZ and VX as congruent. So we need that. The two triangles that are right triangles, they also kind of share a side, but it's in a way that we've never seen it before because the triangles are overlapping. So therefore, for that one, that's our reflexive. So VW would be congruent to VW because it's reflexive. And then the triangles are equal because we have a hypoteni and we have the legs, so HL. And that's the really short version of what all hypotenuse leg is about. And have a great day.